My dear students, welcome back to our channel. In this video, I will be explaining the BCA first semester subject Mathematical Foundation of Computer Science, MFCS, as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2 first important short question is: in how many ways can 5 children arrange themselves in a ring? Arrangements of 5 children in a ring. When arranging objects in a line, the number of ways is simply n. Example, 5 children in a line 5 is equal to 120 ways. But in a ring, circular arrangement, rotations are considered the same. Meaning, if everyone moves one seat clockwise, it's not a new arrangement. Step 1. Use the circular arrangement formula. For n objects in a circle, number of arrangements is equal to n1. Reason: fix one person to break the rotation symmetry. Arrange the remaining n1 people in a line. Step 2. Apply formula for 5 children. N is equal to 5, 5 to 1, is equal to 4, is equal to 24. Step 3. Example to remember. Imagine 5 friends sitting around a table. Rotate the table same arrangement. Only the order relative to the first fixed person matters. Answer: there are 24 distinct ways for 5 children to sit in a ring. Memory trick. Circular is equal to fix 1, arrange rest n1. This is an easy formula to remember for all circular arrangement problems. Next important short question is 2. The number of arrangements of letters in the word Tallahassee. Arrangements of letters in Tallahassee. When all letters are different, the number of arrangements of n letters is: n is equal to 1 times 2 times 3 times n. But in the word Tallahassee, some letters repeat. T appears 1 time. A appears 3 times. L appears 2 times. H appears 1 time. S appears 2 times. E appears 1 time. Step 1. Use the formula for repeated letters. Number of arrangements is equal to np1, p2, pk. N is equal to total letters is equal to 11. p1, p2 is equal to factorials of repeated letters. Number of arrangements is equal to. Step 2. Example to remember. Think of arranging 11 tiles with repeated letters. Divide by factorial of repeats to avoid counting identical arrangements twice. Answer: there are 3,326,400 distinct arrangements of the letters in Tallahassee. Memory trick. All letters factorial divided by repeated letters factorials, easy to calculate and remember. Next important short question is 3. If A is equal to x, y, z, B is equal to x, a, b, and C is equal to a, b, c, then find A times BC. Find A times BC. We are given A is equal to x, y, z. B is equal to x, a, b. C is equal to a, b, c. Step 1. Find BC. BC is equal to all elements in B or C or both is equal to x, a, b, c. Step 2. Recall definition of Cartesian product. A times BC is equal to a, b, b, c. Pair each element of A with every element of BC. Step 3. List all pairs. For x, kiss smiley, x, a, x, b, x, c. For y, kiss smiley, y, a, y, b, y, c. For z, kiss smiley, z, a, z, b, z, c. A times BC is equal to. Step 4. Easy memory trick. Step 1. Find union first BC. Step 2. Pair each element of A with every element of BC. Step 3. List systematically to avoid missing pairs. Answer. There are 12 ordered pairs in A times BC. Next important short question is 4. State the pigeonhole principle with an example. Pigeonhole principle. The pigeonhole principle is a simple but powerful idea in combinatorics. Statement. If n objects are placed into m boxes and n m, then at least one box will contain more than one object. Think of pigeons and holes. If more pigeons than holes, some holes must hold at least 2 pigeons. Step 1. Understand the idea. Objects is equal to pigeons. Boxes is equal to pigeonholes. If objects boxes collision is unavoidable. Step 2. Example. Suppose 13 students are in a classroom and there are 12 months. Question. Show that at least 2 students were born in the same month. Solution. Students is equal to 13 pigeons. Months is equal to 12 holes. 13-12 by the principle, at least one month has 2 or more birthdays. Step 3. Memory trick. More objects than boxes, some box gets extra. Very useful in problems about birthdays, socks, handshakes and arrangements. Always check if objects boxes, then apply the principle. Answer. The pigeonhole principle guarantees at least one box contains more than one object when objects boxes, as seen in the birthday example. Next important short question is 5. Define Cartesian product of sets with an example. Cartesian product of sets. The Cartesian product of 2 sets is a way of making ordered pairs from them. Definition. If A and B are 2 sets, the Cartesian product A times B is. A times B is equal to A, B, A, and B, B. Each element of A is paired with every element of B. Order matters. A, B is not equal to B, A unless A is equal to B. Example. Let A is equal to 1, 2. B is equal to X, Y. A times B is equal to 1, X, 1, Y, 2, X, 2, Y. Step 1. Take the first element of A, 1, pair with all of B. Step 2. Take the next element of A, 2, pair with all of B. Done. Memory trick. Think of A as rows, B as columns. Each box is equal to one pair. Formula for number of pairs, A times B is equal to A times B. Answer. The Cartesian product A times B is the set of all ordered pairs, pairing each element of A with every element of B, as in the example. Next unit 2. Long questions. First important long question is: how many 3-digit numbers can be formed using the digits 1, 3, 4, 5, 6, 8, 9? Number of 3-digit numbers from 1, 3, 4, 5, 6, 8, 9. We are asked how many 3-digit numbers can be formed using the digits. Step 1. Count available digits. Total digits available is equal to 7. 3-digit number hundreds, tens, units, places. Step 2. Decide if repetition is allowed. If digits are different, usual case in MFCS problems, no repetition. Step 3. Count choices for each place. Hundreds place cannot be 0. No zeros here anyway. Choices is equal to 7, all digits available. Tens place, 1 digit used in hundreds, remaining choices is equal to 6. Units place, 2 digits used, remaining choices is equal to 5. Total numbers is equal to 7 times 6 times 5 is equal to 210. So, 210 different 3-digit numbers can be formed without repetition. Step 4. If repetition is allowed, optional, just for memory. Hundreds place 7 choices. Tens place 7 choices, digits can repeat. Units place 7 choices. Total numbers is equal to 7 times 7 times 7 is equal to 343. Step 5. Easy memory trick. List places, hundreds, tens, units. Count available digits at each step. Multiply choices, basic counting principle multiplication rule. No repetition, multiply decreasing numbers. Repetition allowed, multiply same number for all places. Example to remember. Hundreds is equal to 3, tens is equal to 1, units is equal to 5, number is equal to 315. Hundreds is equal to 9, tens is equal to 4, units is equal to 6, number is equal to 946. Keep multiplying the number of choices for all positions gives all possible numbers. Answer. Without repetition, 210 numbers. With repetition, 343 numbers. Memory tip, 3 places, multiply choices step by step, always works for digit arrangements. Next important long question is 2. There are 21 consonants and 5 vowels in English. Consider 8-letter words with 3 different vowels and 5 different consonants. Forming 8-letter words with 3 vowels and 5 consonants. We are asked. Total letters 8. 3 different vowels from 5 vowels, A, E, I, O, U. 5 different consonants from 21 consonants. Letters are all different. We need number of possible 8-letter words. Step 1. Choose the vowels. Total vowels is equal to 5. Need 3 vowels. Number of ways to choose is equal to C, 5, 3. C, 5, 3 is equal to 5, 3, 2 is equal to 10. Step 2. Choose the consonants. Total consonants is equal to 21. Need 5 consonants. Number of ways to choose is equal to C, 21, 5. C, 21, 5 is equal to 21, 5, 16 is equal to 20349. Step 3. Arrange all chosen letters. Total letters chosen is equal to 3 vowels plus 5 consonants is equal to 8 letters. Number of ways to arrange 8 different letters is equal to 8. Is equal to 40,320. Step 4. Multiply all steps, counting principle. Total words is equal to C, 5, 3 times C, 21, 5 times 8. Step 5. Easy memory trick. Step 1. Choose vowels C, 5, 3. Step 2. Choose consonants C, 21, 5. Step 3. Arrange all letters 8. Multiply all total words. Tip. Choose letters first, then arrange, works for all word formation problems. Step 6. Example to remember. Chosen vowels is equal to A, E, I. Chosen consonants is equal to B, C, D, F, G. Possible arrangement is equal to A, B, C, E, D, F, G, I. One word. Multiply all combinations and arrangements total possible words. Answer. There are 8,198,476,800 distinct 8-letter words with 3 different vowels and 5 different consonants. Next important long problem is 3. If E1 and E2 are subsets of U, then prove. Prove. We are asked to find the number of elements in the union of two sets. Step 1. Recall definitions. E1, E2, U, subsets of universal set U. Union E1 E2 all elements in E1 or E2 or both. Intersection E1 E2 elements common to both E1 and E2. Step 2. Idea behind the formula. If we add even plus E2, elements in both sets are counted twice. To fix this, we subtract the intersection even E2. Even E2 is equal to even plus E2 even E2. Step 3. Example to understand. Let E1 is equal to 1, 2, 3, 4. E2 is equal to 3, 4, 5. Union even E2 is equal to 1, 2, 3, 4, 5. Even E2 is equal to 5. Intersection even E2 is equal to 3, 4. Even E2 is equal to 2. Check formula. Even plus E2 even E2 is equal to 4 plus 3-2 is equal to 5. Works perfectly. Step 4. Stepwise explanation. Count all elements of E1 includes shared elements. Count all elements of E2 shared elements counted again. Subtract shared elements, intersection, each element counted only once. Step 5. Easy memory trick. Union is equal to add both sets, subtract the overlap. Always remember double counted elements need subtraction. Works for two sets easily, can extend to 3 or more sets using inclusion-exclusion principle. Answer. Example, E1 is equal to 1, 2, 3, 4, E2 is equal to 3, 4, 5, even E2 is equal to 5. Memory tip, add both, subtract intersection, simple and easy to remember for exams. Next important long question is 4. Determine whether the relation divides on integers is a partial order. Determine whether the relation divides on integers is a partial order. We are asked to check if the relation divides vertical bar on integers is a partial order. Step 1. Recall definitions. A partial order is a relation that is reflexive, every element is related to itself. Antisymmetric, if A is related to B and B is related to A, then A is equal to B. Transitive, if A is related to B and B is related to C, then A is related to C. Here, A divides B means AB there exists an integer k such that B is equal to A times k. Step 2. Check properties for integers. 1. Reflexive. For any integer A because A is equal to A times 1. Reflexive property holds. 2. Antisymmetric. If AB and BA, then B is equal to A times K1 and A is equal to B times K2. Multiply A is equal to A times K1 times K2A, 1 K1 K2 is equal to 0. This is true only if A is equal to B or A is equal to 0, B is equal to 0. So antisymmetry holds for positive integers, but fails for negative integers because 2 and 2 but 2 is not equal to 2. 3. Transitive. If AB and BC, then B is equal to A times K1 and C is equal to B times K2, C is equal to A times K1 times K2. Transitive property holds. Step 3. Conclusion. Divides is reflexive. Divides is transitive. Antisymmetric only fully holds for non-negative integers. Hence, on all integers, divides is not a partial order, but on positive integers, it is a partial order. Step 4. Example to remember. Positive integers, 2 vertical bar 4 and 4 vertical bar 8 to vertical bar 8. Negative integers, 2 vertical bar -2 and -2 vertical bar 2 is not equal to -2. Memory trick. Check reflexive, transitive, antisymmetric, only positive integers safe for partial order with divides. Answer. Relation divides on integers is not a partial order, fails antisymmetry. On positive integers, it is a partial order. Next important long question is 5. If f(x) is equal to x3 plus 2x2 plus 3x plus 1, find f minus 2 f x1 plus f x plus a. Given function f(x) is equal to x3 plus 2x2 plus 3x plus 1. We are asked to find f minus 2 f x1 plus f kiss smiley f x plus a. Step 1. Find f minus 2. Substitute x is equal to 2 into f kiss smiley. F minus 2 is equal to minus 2, 3 plus 2 minus 2, 2 plus 3 minus 2 plus 1. Step by step. Minus 2, 3 is equal to 8. 2 minus 2, 2 is equal to 2 times 4 is equal to 8. 3 minus 2 is equal to 6. Constant is equal to 1. Add them. 8 plus 8 dash 6 plus 1 is equal to 5. Answer f minus 2 is equal to 5. Step 2. Find f x1 plus f kiss smiley. First, substitute x1 into f kiss smiley. F x1 is equal to x1, 3 plus 2, x1, 2 plus 3, x1 plus 1. Expand each term. x1, 3 is equal to x3 dash 3x2 plus 3x1. 2 x1, 2 is equal to 2, x2 dash 2x plus 1 is equal to 2x2 dash 4x plus 2. 3 x1 is equal to 3x3. Constant is equal to 1. Add all. Now add f x. Answer f x1 plus f x is equal to 2x3 plus x2 plus 5x. Step 3. Find f x plus a. Substitute x plus a into f kiss smiley. Expand using formulas. Constant is equal to 1. Combine like terms. Answer f x plus a is equal. Step 4. Memory trick. F number just substitute. F x1 or f x plus a use binomial expansion. F x1 plus f kiss smiley. Expand each and combine. Tip: do step by step to avoid mistakes in powers and coefficients.